Hi, my name is David Maloney, and today I'm going to be presenting to you my research analyzing the effectiveness of America's transit systems to promote widespread use of public transportation. Quite frankly, the goal of this research is to find ways to encourage people to take more public transportation. This research is designed to analyze the effectiveness of America's largest transit systems to provide policy suggestions for the future for how other systems might want to improve their efficiency. Accessibility and efficiency in transportation are vital to the economics of a city. Now more than ever, people need to be taking public transportation given the negative implications that private vehicle use has on the environment. So when accessibility increases, economic growth increases, and when transit ridership increases, urban carbon emissions decrease, and that's a good thing. It's a good thing because urban transit is currently the single largest source of global transport-related carbon emissions and the largest local source of urban air pollution. Cities with increased access to public transportation are cleaner. So getting people to take more public transportation is a first step to getting cities cleaner. But getting people to take more public transportation requires systems to be more efficient, and which requires the analysis that I've done. If you look at table 1 here towards the left, in that top row, we see Hong Kong, which is a very dense urban city, where nearly 84% of the population uses cycling, walking, or public transportation as their main mode of moving. As a result, they have just 378 kilograms of carbon emissions per capita per year. And that's in contrast to Houston, in the bottom row there, with nearly 5% of the population using public transportation, walking, or cycling as their main mode of transportation. As a result, they have 5,690 kilograms of carbon emissions per capita per year, much higher than that of Hong Kong. And Houston is a very good barometer or model for most American cities where private vehicle use is very high. Analyzing transit data is complicated. There are many variables to consider when analyzing how a transit system achieves its efficiency, but they include but are not limited to population, economic development, number of vehicles, environmental influence, travel demand, transport supply, traffic congestion, even things like the weather. These all play into how a city can deliver its efficiency of its public transportation systems. The purpose of this research is to correctly analyze the efficiency of different transit systems across America, view how those agencies achieve their efficiency, and how that can be applied to other transit systems in the future. This research is much more similar to that of a statistical analysis paper, and not like your typical research papers. The methods for this research paper included conducting background research on different transit systems, but data was eventually collected using the National Transit Database sanctioned by the United States Department of Transportation. Basically, every year, every transit system in the country, whether it's a small regional bus service or the Metropolitan Transit Authority of New York, they all have to report the same vital statistics and metrics to the Department of Transportation, and that's where I found my data. So the data between the cities and their transit systems is all the same. The data needed was collected, calculations were made, and put into tidy data format for analysis. The data was put into 3 scatter plots on dataclassroom.com. 1, average age of fleet versus proportion of scheduled revenue miles met. 2%, of spare vehicles in fleet versus proportion of scheduled revenue miles met. And 3, proportion of scheduled revenue miles met versus the change in ridership from the previous year. In our case, we're going to use proportion of scheduled revenue miles met as our metric for understanding the efficiency delivered in cities. So data was then compared to, after the analysis portion, the data was compared to the transit agency's year-end reports, compared to ridership trends, and lurking variables such as the rideshare services such as Lyft and Uber were even taken into consideration during the analysis and policy suggestions section. But I also had to take into account the economy, and that played an even bigger role in ridership. Here we have the first results, average age of fleet versus the proportion of scheduled revenue miles met. In this case, we see an association that is weak, slightly negative, and nonlinear. In our case, we're going to use the coefficient of determination, or R-squared valued, as our statistic for revealing the association. In our case, for our purposes, the R-squared valued represents the proportion of the variance for a dependent variable that is explained by the independent variable. Frankly, what that means is the closer to 1 the R-squared valued is, the more association there is. The further away from one the R-square value is, the less association there is. So in our case, with the R-square value of 0.00505, there was little association between the average age of fleet versus the proportion of scheduled revenue miles met. Continuing on, we see proportion of scheduled revenue miles met but this time versus the percent of spare vehicles in the fleet. In this case, we see a slightly more positive, moderate, and relatively linear association. The R-square value of this test is 0.289, revealing that nearly 29% of the observed proportion of scheduled revenue miles can be predicted by the percentage of spare vehicles in the fleet. This is a stronger association than the 1% in percent of spare. This association is stronger than the 1% in the average age of fleet versus proportion of scheduled revenue miles. And finally, we see proportion of scheduled revenue miles met versus change in ridership of the previous year. This is efficiency versus ridership. Again, we see an R-square value of 0.085 and a moderate nonlinear positive association. This low R-square value once again reveals that there's little to no association between the efficiency and service delivered versus change in ridership from the previous year. There were many outliers in every plot. The system with the lowest percentage of spare vehicles was New York, for example, but it still achieved more than 90% of its scheduled revenue miles. And the data are not clear-cut and varied greatly. Although some of the dependent variables can be predicted by some degree of variability, the majority cannot be. Despite many transit agencies achieving near 100%, many still saw losses and decline in ridership. And lurking variables such as the strong economy and rise of rideshare services such as Uber and Lyft contribute more to the decline in ridership than efficiency. The thinking behind this project was that the younger the fleet and more spare vehicles available, the higher the proportion of revenue miles achieved, and therefore would be higher ridership, and that would pave the way for clear policy suggestions and future work. But the low R-square values revealed that there is little to no association, and that this led me to conduct some more research on the effect of the economy, for example, on ridership. Like I mentioned, despite efficiency of nearly 95% of revenue miles achieved on nearly all transit systems, every agency still saw the ridership decline from the 2016-2017 year. In 2019, a transit center survey was conducted, polling many Americans across all demographic groups across the country. And in that poll, they found that 54% of respondents said that they had full-time car access, up from 43% 2 years ago, revealing how the economy truly affects transit ridership. When the economy is better, car loans are more accessible and vehicles are more affordable to the average American, and as a result, transit ridership decreases. So it is hard for me to provide policy suggestions for the future. Efficiency does have some effect on public transit ridership, but it's very marginal. So increasing the percent of spare vehicles will increase efficiency, but there's little to no suggestion that efficiency will increase ridership. I would also like to remind everybody that this research was conducted at a time when the economy was much more robust prior to the COVID-19 pandemic. So if this research were to continue in the future, there'd be several changes I would make. One of them would be analyzing the economy versus ridership trends and its main impact on vehicle ownership, which in turn affects the overall ridership of the economy, overall ridership of transit. So one might analyze in the future the more historical role that the economy and private vehicle use has on transit ridership. As we know, the car and car culture are very ingrained into the psyche of the American public. And so examining that more historical role might be more beneficial for transit systems to understand how their ridership might change in the future. Thank you.